So just to let you know, Stephanie's going to be recording the webinar today so that we've got the option of putting it up on the website and we can then refer back to it. So please can I welcome you to the webinar where we've called it Planning for the New Clinical Engineering. Sorry, I've just had to let somebody in there. Planning for the new Clinical Engineering STP 2022 curriculum. Now, the reason that we felt the need to put this webinar on is because there's been quite a considerable change in the curriculum. We have described in the summer what that change was and what the concepts were behind that change. So I urge you to re-listen to that webinar if you haven't had the opportunity to. So next slide, please, Stephanie. So we advertised this event on the website. I just want to let you know now, it does say that it finishes at 1 o'clock. I think Stephanie sent out the invites and it is an hour long. We do have quite a lot of information to put across. So I hope that we don't pen too much on your lunch hour. Okay, next slide, please, Stephanie. So how, oh, hold back. So I'm just going to have to move this out the way. Right, okay, so as we all know, the STP scheme has a master's part and a work-based placement part. And in order to get a master's qualification, you need to get 180 academic credits, which is equivalent to 1,800 hours of study. So as well as university contact time, you need to determine a day a week for study within your training plan. So the structure of what we've put together, Adam will again talk about how King's is implementing this practically, but in the first year we have 60 credits. So Stephanie, if you could just press the, that's it, in which there's the underpinning academic knowledge for all the rotations, and again we'll talk about that in a bit. And also Stephanie, if you could press the next one, it's looking at the professional foundation for healthcare science. So that's the 60 academic credits. Again, Adam will talk about how the modules are divided up for that. Then in the second year, we've got 2 specialism modules, one that again is 10 credits and another that's 10 credits. And then in the third year, Stephanie, if you could do another, we've got a specialism module that is 15 credits and another one that's 15 credits. And the rest of the credits are taken up by the STP programme. So those in the sort of mid blue are where we have work-based placements associated with them. Those in the dark blue is a very general module that goes across all specialisms, and those that are green, there will be a work-based element to it, but not too much. So again, Adam, if you could just press the next space bar, Stephanie, for me. Adam is going to be talking about that part. So very quickly onto the work-based placements. So next slide, please, Stephanie. So the first part we're going to look at, if you could just press the space bar for me. We've got here, we have 10 work-based credits for each module. Well, when we talk about 10 work-based credits, we actually mean, if you press the next space bar, 10 competencies. So again, Stephanie, space bar. So we've got the term for the new curriculum is phases, which roughly fits into years, but it does mean that if you finish your first phase, you can start the second phase, and there's lots more flexibility. So Stephanie, if you could just press the next space bar for me. So the first year is very flexible, and again, Caroline will talk very much more about the flexibility of that. So you do a bit of induction, next space bar. And then attend the university, and then you've got 4 modules. So Stephanie, if you can just press the space bar 4 times for me, which you can do in any order. You can do them simultaneously, however it works, and you can even start part of phase 2 in between if necessary. And then within phase 2, again, Stephanie, if you can just, so Caroline's going to talk about that. We've got a work-based module in which Adam's going to talk about the analytics, And then there's another workplace module that happens in the first year, second year, and then builds up into another module in the third year, which Beth is going to talk about, if another space bar. And then finally, in the third year, there is also a module that Caroline's going to talk about called the patient pathway. And then throughout those 3 years, we've got some core modules. So we've got the professional foundation. We also have the new equivalent to the elective, which again I'll talk to you about, and then finally obviously the underpinning master's programme, the STP projects again, which I'm going to talk about. So Stephanie, if you could just do the next space bar. Yep. Okay. And then next slide. So this is the running order of today, and I've spoken for far too long. So without further ado, then we'll pass over to Caroline to talk to you about, no, not Caroline, sorry, Richard, to talk about setting the scene. Sorry, Richard, nearly missed you out there.
No problem. Okay, thank you to Emma for setting the scene and introducing us. For those of you who don't know me, I'm Richard Scott. My current role is Director of Medical Physics and Bioengineering at University Hospitals, Bristol and Western NHS Foundation Trust. I've spent my life working in clinical engineering as a clinical scientist and chartered engineer, and I'm delighted to be here just helping set the scene and take an overview. I haven't got any slides. I just wanted to sort of start off by posing us all the question: what is it we're trying to achieve? What are the outputs of this program? Clinical engineers make a great contribution to healthcare, working in a diverse number of fields. But what we have in common is we are using engineering principles and practice, hopefully for some kind of patient benefit, and with the use of some kind of technologies. So I don't want to get too bound up in terminology, but we're talking about trying to create engineers who can spend a career, hopefully working in the health service, possibly in other settings, commercial ventures, but with a view to getting value out of technology to benefit patients. And I'd like to sort of pose to all of you a sort of bit of homework when you leave the seminar. What is it you're trying to achieve? What do you want from your clinical engineers going through the clinical scientist training program? We have engineering technologists working alongside us. So I think it's really a point of reflection now where we can think, what is it we're aiming to achieve? We've had the previous STP curriculum running for some 11 years now. And this new curriculum gave us the opportunity to sort of think, well, what had worked well and what do we need to do differently? Since we wrote the original curriculum, there's been a lot of change in the organisation and vision of the NHS. We've got the NHS long-term plan talking about, you know, how we design a fit for purpose health service for the 21st century. Technology has changed dramatically as well with an explosion of digital technologies. And our curriculum, as we have been delivering it, was fairly focused on delivering trainees at the end who could work in either rehab or device risk management or clinical measurement and innovation. And those are still important areas, and we still want to produce engineers who can work in those fields. But we also need to think more broadly. I've had a lot of discussion with trainees over the years, and having gone through those individual specialisms, trainees have sometimes felt constrained that they could only apply for jobs in the specialism they trained in them. So one thought behind this curriculum was trying to give our engineering trainees the range of skills that would enable them to feel confident to apply for any clinical engineering job that comes up at the end of their training. Also to allow us to be able to deliver a more flexible workforce going forward. We're going to see the NHS in England divided into integrated care systems. And I would argue we need a lot more clinical engineers. There's some fantastic skills our engineers have in their various specialisms, but those skills could be offered to wider patient populations. So I really just wanted to get you thinking. I believe this new curriculum can still let you deliver training that reflects the specialisms within your department. And it's great that trainees will be exposed to whatever it is your department does. But we would also ask you to look at the way we've engineered this curriculum so that it develops rounded engineers with analytical skills, engineers who understand patient pathways and how to liaise with patients, how to apply engineering in a clinical setting with a strong vision of innovation. So I've been really excited to see the curriculum evolve, and it's even more exciting now to think how we're going to deliver it. But I would ask, as I draw to a close, that you just take some time to sort of stand back, reflect on this, and see how you can apply it. I'm hoping it will open up for many smaller training centres the opportunity to take clinical scientist trainees to build their wider clinical engineering workforces. I'll draw to a close there. Thank you for listening, and I hope you enjoy the rest of the seminar. Thank you.
Thanks very much there, Richard. So can I pass you over to Caroline now?
Thank you very much. Yes, I'm going to talk through the rotations. Next slide, please. Thank you. So the rotations sort of came at us slightly by surprise when we were putting the new curriculum together, because in the old world, with separate clinical engineering specialisms, we were able to rotate to each other, to rotate our trainees into different specialisms. And suddenly in the new curriculum, we are one specialism, and then we had to look for rotations elsewhere. And there are lots of clinical science specialisms, as you know. Initially, this felt like a bit of a downside of the new curriculum, because it felt like something that was a little bit artificial. But actually, I think it's possibly one of the very positive features of the new curriculum. But this is probably the bit that's going to take most thinking about, especially as it's going to come at us in January next year when our trainees emerge from their term at King's. So just a quick overview. We know that the current curriculum has 4 very familiar rotations in our main specialist areas. We're used to delivering those. We're used to working with other people to deliver those. And so for the new curriculum, we've only really got 1 home rotation, Introduction to Clinical Engineering. After that, we are sending our trainees off to other areas. And we wanted to think about which areas we would like them to go to. And these 3 areas were chosen very carefully to reflect really the natural partnerships that clinical engineers make. The new rotations are also different across the STP. They are less about doing actual project work. They are more about experiencing, reflecting, understanding, pursuing curiosity, and they can be shorter. What that means is that in the new rotations, there's a lot of potential for being really quite creative with them. I think you'll find that the rotational year is less pressured in terms of delivering separate projects, and there are more opportunities for exploration. We're also seeing the rotations as patient pathway 1. So you'll see as we're in the second year, we're diving off into technology and analytics. And actually, the patient pathway doesn't come back in until the 3rd year. But we're seeing this as the foundation for understanding what the patient pathway looks like. So I'm just going to pick up the themes that that Richard talked about at the start as a way into thinking about how to plan this first year. So what's the potential of the new curriculum? I think these are the things at this stage, as we're, a few months away from receiving our new curriculum trainees, are the things to be thinking about. So what kind of experience do you want your trainees to have during their training? We've designed a new curriculum for a purpose, which is to produce clinical engineers with breadth and imagination and creativity, and also engineers who are happy in all sorts of environments. So we're getting new graduate engineers who haven't been in clinic before, who aren't familiar with NHS worlds. And what we want to do in this first year is get them out and about, get them used to being in different places, different clinical settings, actually interacting with patients. How do we inspire them and equip them to do that? We've also got in mind that our trainees are being prepared for future, hopefully long careers in the NHS, in engineering and down the line in management. And there's a lot of strategic change going on in the NHS, boundaries are breaking down, and we want trainees who will be able to go out and make an impact across a huge number of areas. And we need to be thinking, as our new trainees appear with us, what do we think they're going to need for their careers, which is probably different from what we've needed for ours. And what sort of understanding are they going to be able to have to lead innovation and change across the NHS in areas that are not just clinical engineering? And so in these rotations, the trainees are going out into areas that are not familiar clinical engineering areas. There's also an opportunity for each of our services to think, what specialisms would we like to spend more time talking to, working with? And having a trainee is a great opportunity to say, actually, you know, I know that our patients cross other pathways. We don't have a lot of time to liaise with the clinicians involved. This might be the opportunity for us to use our first year rotations to establish new relationships within our own trust, or with a very different kind of trust. So we could think about, you know, we're in Oswestry are a small specialist orthopaedic hospital. We want our trainee to be able to experience larger trusts, different settings. And the new curriculum rotations are going to be a really good opportunity to think about broadening the trainees out, getting them confident, getting them to apply their curiosity in all sorts of areas. So they're all set for their specialist training in years 2 and 3. So just running through these 3 rotations away from clinical engineering. So we decided that physiological measurement was a key area for our trainees. We spend a lot of time telling our trainees not to go competency bagging, in the sense that the training programme is not set up for them to go and tick off competencies unthinkingly. What we want them to do is have a really good positive experience, and at the same time collect competencies almost as a byproduct of that. If you wanted to be very efficient in terms of physiological measurement, you could probably use your existing clinical measurement contacts from the old curriculum and our clinical engineering colleagues. But there's actually a very wide range of physiological measurement specialisms out there. I've listed some on the slide there. So how many of those do you want to try and get your trainees exposure to? There are some requirements, so they need to deal with imaging data, they need to see collection of physiological signals, they need to deal with mechanical measurements of things like pressure and flow. But think about it more broadly. Which of these do you think the trainees would like to see? And they will go into those areas with their clinical engineering brains. So they'll be looking at, how do we measure things? They'll be looking at, how do we manage the equipment? They'll be looking at how is assistive technology used? But they will be doing it in a whole range of different areas, and hopefully it will inspire their creativity and broaden their outlook, as well as building some new networks of connection. And as Richard was saying, the NHS is undergoing some strategic change, and thinking particularly here about the Richards reports, encouraging diagnostic services to work together and create some new infrastructure. This may be a very good way of forging some links with some of those related areas. We're always going to be a small profession, or at least we are at the moment, and getting some really good links with other players is going to be key to us in the future. The clinical and scientific computing, they are the ones who want to come to us. So there's generally an exchange of rotations in the first year. So your trainees go to another specialism, the other specialism's trainee come to you. That's only true for us, for the clinical scientific computing folk. But that does mean that you should have some deals to be struck if you know who's got trainees in that area. And that's maybe something that we can work together on to find out which training centres have got trainees in clinical and scientific computing, to see if we can set some exchanges up. But there's huge potential here. And I think we've all spoken previously about the potential of clinical engineering to transform healthcare, and transform it through devices and technology. And we know that there's going to be a lot of infrastructure, data storage, intelligent devices, network devices, apps and different software requirements, all of which are going to feed into the role of clinical engineering in the future. So this is a great opportunity for trainees to go and meet the specialists in that area, and again think about how it applies to their own area. Lastly, medical physics. Medical physics and clinical engineering are probably naturally related allies. They're the physical scientists in the specialism, as we are. So we've got a lot in common. We've actually got an awful lot of difference as well. I was involved in the discussions around the introduction to medical physics rotation, and realised just how differently I think about things as a clinical engineer compared with the medical physicist. And I think our trainees will enjoy being out and about in medical physics, seeing how the physicists approach things, and they will have some very interesting conversations, I think, when they're working with clinical scientists who are medical physicists. There will be a lot of overlap, and there will be some difference as well. And the medical device interest is going to be significant in this. And again, I think you need to think about, where are your medical physicists and what are they doing, and how wide a range of medical physics would you like your trainees to see? That might mean using your own trust. It might mean sending them around a few trusts, because your trust might not do radiotherapy, for instance, and you'd like your trainee to have experience of that as well. I think one of the things we've been thinking about in our local training network is what to do about our old friends. So we've had friends who have helped us with delivering the rotations in the old curriculum, and suddenly we're going off getting new friends for the new curriculum. And I think where the old friends will really come into force is in years 2 and 3. So as we hear more about years 2 and 3, you will realise that if, like us, you're a rehabilitation engineering centre, you are going to need your other clinical engineering specialist friends to deliver years 2 and 3 of the training. So one way to look at the old rotational contacts is they get a year off next year. And they get to worry about delivering the new curriculum themselves, and they won't be getting lots of your clinical engineering trainees trailing through. But after 12 months, you'll be back knocking on their door saying, actually, I've got some specialist competencies that I'm not set up to deliver in my local rehab engineering service. Can you help us with? So I don't think we're losing our old rotational contacts. What we're doing is we're pushing them into the specialist training, and that's where we'll suddenly see how all the connections play out with across the spectrum of clinical engineering. So I think that leads nicely into talking about the specialist rotation. So I'll hand over to Beth.
Great, thanks very much. Thanks very much, Caroline, for that. So yeah, thanks very much. And yeah, on to Beth.
Thanks. Can I have the next slide, please? So before I get stuck into the actual content of the two modules I'm going to talk about, I just wanted to point out something which should be really obvious, but if you haven't yet had a chance to have a good poke about the new curriculum on the school's new website, you might miss this, and it's really helpful. So when you reach the competency pages, there's a lot of information there alongside the competency itself. So don't just read the competency, scroll all the way down the page to where you'll find the learning outcomes and the clinical experiences and the indicative content. And further up the pages, where the competency is described, you'll see a view link. If you click that, you will get the image as I've shown on the screen here, which again repeats your competency information and the details, but gives you some considerations. All of that supplementary information is quite key in helping you as trainers get into the minds of those who developed the curriculum and what we were really hoping to get out of each competency and the training experience we were aiming for. Next slide, please. So obviously I've only got 10 minutes to talk through 2 modules, so I'm not going to talk about every competency in turn, but what we're looking to do is give you a few ideas as to what we meant by that competency and how you might go about achieving it in your training plan. In healthcare technology management, some of them are going to be very familiar to you, as they are very similar to what you'll have seen in the old device risk management and governance specialism or rotation. Others are a bit new and might leave you scratching your head a bit more. So, for instance, one of the first ones is presenting the impact of a change to a healthcare technology management service. This is new. So we're trying to start the system thinking already. We're trying to get the trainees to see more than just the small job or a small change in front of them and understand the ripple effects that could have and the risks and the benefits of those changes. So in that competency, when you have a look at it, we will have suggested using things like mapping techniques and mapping methods. Don't panic if this is something that you're not familiar with, because the MSc will be picking up and providing our trainees with ideas of mapping methods. So as trainers, we might be a little bit unfamiliar with some of the content that we're asking our trainees to do, but what we're asking them to do will be supported by the MSc that's being delivered alongside the training. So moving further down that list, we have, thank you, we have undertaken an options appraisal and evaluation. And again, here we're trying to get the trainee not just evaluate 1 or 2 devices in front of them. We're wanting them to look at more than the technical specification. Next slide, please. Competency 6, looking at non-conforming devices for clinical and research use. We felt this is quite important. It's a reality that not every device we end up using in a hospital is a CE-marked medical device that's come through the normal conformity routes. We have had people in OSFAs in the past state, when questioned about non-conforming products, well, you can't use them. Obviously, that's the first thing the first answer we try to give people, but it's not reality. And there are ways in which we can safely manage non-conforming devices. So we want the trainee to have some experience of what the correct pathways are, both within your organisation, but actually more holistically, what needs to happen to put these devices safely into use. So I'm sure you'll have some examples, whether it's a fresh example or whether it's an older example or even a theoretical one if it needs to be. But I think there's a lot of options for what you can use. We've taken a slightly different ethos. So in the old curriculum, we gave types of devices where we would expect our trainees to be able to operate on. So in terms of electrical safety and performance, we don't do that now. We've just stated that we're looking for the trainees to look at a range of medical devices, and we're asking them to be able to look at the electrical safety, the essential performance, so meaning the real essential performance of that device. So what is its aim? Was it delivery? Is it diagnostics? Is it therapeutics? And to understand how you would go about verifying that and the safety mechanisms of those devices. So we're not just looking to be able to say the trainee can work on these three different types of device. We're wanting to know that if they went into a new job or a different service and had a different device in front of them, they have the knowledge and the understanding to be able to approach it sensibly and to do the right thing. And actually, competency 10, clinical measurement. Competency 10 is looking for our trainees to understand the clinical relevance of the device that's being used. So although this is down in the healthcare technology management module, this will obviously be relying on the trainee having spent time in those clinical areas. And as Caroline said, I think it's really important to realise that we've written this curriculum with the aim that if you're a rehab centre that doesn't have a medical device governance team on hand, or whether you're an MESU service who doesn't have a lot of clinical input around you, everybody can deliver this curriculum with a bit of help from their friends. So we would be expecting here for the trainee to be getting experience from the rotations and from the clinical work they have done to support their knowledge and understanding about the technology they're using. And I think it works from both perspectives. So in services such as mine, where we don't have such close clinical links, we are going to have to ensure that our trainee goes and spends the time with our current friends and some new friends we make along the way. Next slide, please. So moving on to healthcare technology innovation, we've got 15 competencies here that we're looking at. And I think this module is quite different to our old curriculum. It does have close links to analytics. So I think it's certainly worth reading through both competency sets side by side, because you will find links. And I will point out some of the developments or some of the competencies that you can take from analytics and move it through into innovation. So the first three competencies, we're expecting the same project or the same need to take you through competencies 1, 2 and 3. So competency 1 is looking at generating requirements to address a service need. That moves through into identifying possible solutions, gaps and opportunities for that initial solution, and then moving through to presenting what those solutions are to a stakeholder group and leading the appraisal of those options with stakeholder group. So they should flow quite nicely together. Competencies 4 and 5 are more about generating a prototype and simulating. So that could be further developing the project that you've looked at in 1, 2 and 3. But we are really looking for some electronic or mechanical output or some simulation in CAD. And again, that links back to some of the analytical competencies. And once you've got a prototype or a simulation, we want to know that the trainees can properly go about verifying and validating. So planning for verification and validation and undertaking verification and validation activities. Next slide, please. I'll jump ahead slightly just to confuse you. But if you haven't produced something mechanical or electronic even, for those previous few competencies, when you get to competency 10 and 11, you'll see that we actually then are asking the trainee to do a bit of practical work. So if they've managed to avoid it so far, competency 10 and competency 11 on the next slide, which is exactly the same, but just for mechanical, we're looking for the trainee to build and test something electronic and similarly something mechanical. It doesn't have to be incredibly complex. These can be projects that you just set up and roll out year after year for trainees if you're not in a department that routinely does this. And hopefully that delivery model would also make it easier if you're needing to find a friend to support you with those particular competencies, because it means that those that are supporting you, again, can have off-the-shelf builds for electronic and mechanical examples that they can work through, just so we know they've had some practical experience of doing those. Moving backwards then to competency 6, we're talking about business cases. So again, ideally, this would be a real business case for something that's going on in your trust. But it could be a theoretical one, or it could be looking at something for a stakeholder service around you. We're looking for critical review in number 7 of a new technology or a mass equipment replacement programme. So we're aware that some organisations don't, especially if you're not an equipment management service, won't have a lot of these going on, which is why you've got with it being a retrospective exercise, friends can support you with offering some examples, or you might have something from your own service that you can utilise. I think, can we move on to the next slide, please? A pathway of innovation translation. Again, this is very new. We're wanting trainees to understand key requirements along the way from a new innovation all the way through to innovations becoming a part of routine healthcare delivery. We're not expecting them to chart something moving along that pathway, because that takes many years and potentially many years longer than the STP training scheme. But we're wanting them to demonstrate and be able to describe what that pathway is and what the key requirements are along the way. It's likely that in later years, so not necessarily as they first move into a band 7 clinical engineer post, but shortly thereafter, they are going to be relied upon to give accurate guidance to colleagues within trusts on such things. So it's good for them to start understanding it and being able to articulate it early. And we've brought in number 14, evaluation of diagnostic performance. So we felt this is quite a key skill even, regardless of a training base that the trainee comes from. And I don't think we had anything similar to that in the old curriculum. And then finally, asking them to understand innovation and impact on a service or clinical pathway. And again, this comes back to the key element of systems thinking. There's a lot of systems thinking across our curriculum, but I think it really is key to the future clinical engineer. And there must be innovations going on in services around you, even if you don't have one of your own, that with speaking to some colleagues you can utilise for your trainee, and hopefully bring some benefit to those stakeholders thinking about making those changes. And that's the end of my slides, thank you. So I will pass you over to Adam.
I think actually it's passing over to Caroline.
Oh, sorry, Caroline.
Not to worry. So if people do have any questions, do put them in the chat and we will then address them at the end. So if you have any questions as we go along, please don't hesitate to put them in the cache. Okay then, Caroline, if you could quickly go through the patient pathway, that would be great.
Yeah, I've just got one slide for this actually. I think what I wanted to say about this really was that in some ways this is third year. It feels a bit odd in that we think surely these trainees are going to be patient focused all the way through, and that's definitely true, certainly starting in the rotations, and it is assumed through the second year that they will be very patient focused. When we come to the third year, we're making it explicit. And we're making it explicit that these trainees will stand as independent clinicians. So I think one of the reimagining jobs that we have to do as clinical engineers is think about who we are in this NHS workforce, which is so diverse. And actually we fulfill so many different roles. And I think thinking about how many of those different kinds of roles we want our trainees to be able to undertake is quite important. But what we all agreed was important in the new curriculum is that our trainees should be very comfortable and happy facing an individual patient in a clinical setting. Now that is familiar territory for rehab specialists, possibly less so in some of the other areas. So we want to make sure that all our trainees, whatever their background, are happy and comfortable dealing face to face with patients and with as wide a range of other clinicians within the MDT team as possible. I just collected the verbs from the these competencies within the patient pathway and clustered them. So I think there are 4 different clusters. On the left-hand side, there's the explain, train and educate. So we need to turn out some really powerful clinical communicators in our new clinical engineers coming through. The left-hand list at the bottom, interview, assess, prescribe, review, recommend, report, is basically be a clinician. Go into your clinical engineering service and see the whole clinical process through with a patient. And we want our trainees to be able to do that all the way through. And then at the top right, classic clinical engineering territory, be able to innovate, appraise and critique. Go in everywhere with a critical mind, looking at data, being able to challenge, being able to innovate. And then lastly, the 4th cluster, plan, manage and audit. There are some obviously logistical and planning tasks involved in the managing of complex services, and we want our trainees to be competent and capable in those areas as well. So we're really looking at clinicians plus coming out of this, people who are happy to be in a clinical environment with patients, but have a wide range of skill sets to draw on at the same time. But go and have a look at the individual competencies and you'll see how that hangs together.
Great, thanks very much, Caroline. So I think there's 2 title slides here, Stephanie. So if you want to go through to the next one, because Adam's going to be talking about 2 things. He's going to do the analytics and the academic side. And then I think the next slide is Adam's first slide. There we go. Over to you, Adam, then to tell us what we need to know for the rest of the training program.
Thanks very much, Emma. Yes, so I'm going to try and combine these. I'm Adam Shortland. I'm the Programme Director for my sins of the MSc in Clinical Sciences, in Clinical Engineering stream. But I've been a practicing clinical scientist for a very long time and seen trainees go through my service and other services over that period. And so I come with this with 2 hats. I am an academic, but I'm also run a unit and trainees pass through them. So I have appreciation of both sides. Next slide, please. Yeah, I'm going to start off with the context of the HCPC standards of proficiency for clinical scientists, because I think it's really interesting how that, in a sense, perhaps indirectly, has informed our revisions of the curriculum. We'll talk particularly 1 slide on the analytics pillar and what you might expect to do under that. And then we'll talk about the highly revised curriculum, the MSc curriculum. So next slide. It's interesting, isn't it? I don't know how many people read these things, but it's interesting to read what the HCPC expects of us. And one of the things I like about it is this idea of practicing as an autonomous professional. I think often clinical engineers are seen as support people, but what the standards demand of us is to be an autonomous clinician, and that requires of us something else, perhaps something we're not quite used to. Next slide. Thanks. There are lots of proficiencies in there which are really relevant to the new curriculum. So we've got a little bit of we've got a little bit of a focus on systems and data analysis and analytics and the rest. And if you look through the standards of proficiency, you'll see how well they're facilitated here. How well they're described. To be able to identify the clinical decision which the test or intervention will inform. These are very highly analytical skills, presenting complex ideas to others. That sort of thing, being able to interpret data, requires a sound foundation in statistics. Next slide. And yes, and then there's the research. Oh, yes, next slide, please. Sorry. Oh yeah, got it. Sorry, thank you. No, go back. Sorry, I'm looking at two sets of slides at once, and that's rather confusing me. And then we've got the R&D standards of proficiency, and they're interesting as well. And I wonder how many of us actually fulfil these in our day-to-day clinical scientific lives. But we should be. And there are lots of things here that require sound foundation in research, a sound foundation in statistical analysis, a sound foundation in research design. Next slide, please. And I think a nice way of thinking about the transformation from the old curriculum to the new curriculum is thinking about the movement from a specialist in rehab, clinical management, or HTM to a versatile. And what does versatile mean? Versatile is someone who can be a specialist for a particular discipline, while at the same time being able to change to another role with ease. So I think Richard and Caroline have mentioned that it's perhaps difficult formally for people to make the transitions between different specialisms within clinical engineering. And what we're hoping of this new curricula is that the training and the academic curricula, is that they'll be able to facilitate those changes. Next slide, please. Let's talk a bit about the analytics pillar. Now, on the right-hand side here, we have an interesting diagram about flows of patient movement, patient processing within a hospital. But this diagram, causal diagram, could equally be a physiological, pathological description of a process or a clinical description within department. So what we're trying to do in the analytics pillar is to help people have the tools so that they can investigate the systems that they come across. So Caroline mentioned the rotational placements. Imagine a trainee going into a physiological measurement department. They might want to map that department, so they have an immediate understanding of how that department works. And by using mapping techniques of different types, concept maps, causal diagrams, etc., they might be able to map the process, the operational process. Indeed, they might even be able to map or model the physiological process as well. And we hope that trainee students will get used to the use of mapping tools. And if you've got a map and you've got a model, you want to validate it in some way. And so you'll need statistics to investigate the relationships of elements within that map and that model. So they'll be doing that. And then not to forget the practical skills, which Beth has talked about. There will be elements where they'll have to do CAD and FEA and functional analysis of systems, as well as electronic skills development in the form of simulation. So let's turn our attention to the clinical engineering contents. The next slide, please. So the MSc in clinical engineering comes in essentially two parts, really. There's the foundation material. Previous slide. Sorry, I'm going to chat for a second. There's a foundation material, which is 75 credits in the first 3 months of the student's training experience. And we hope, therefore, to support their training rotations in Intro to Medical Physics, Physiological Management, Clinical Engineering, and Computing by the content in that first 3 months. Now, I think it has been a fair criticism of the previous MSc that we've left some critical elements or later in the later years of the MSc, but this time we've made a real attempt to facilitate these training rotations within that first term. Specifically, we've mapped the training competencies onto the academic competencies, and that's a key thing in these new curricula, that we've actually went through a rather systematic process of demonstrating, at least to ourselves, that we have echoed the training learning outcomes and with the educational ones. We're very fortunate at Guy's and St Thomas's, which is effectively where this MSc is based, that we have lots of clinicians in the different areas of clinical engineering who can make contributions as clinical experts, if you like, to the curriculum, and that's a big plus. Next slide. Previously, we've used MATLAB as our sort of programming base, but we're turning our attention to Python. And my school in KCL has great materials for the development of Python skills. And there are very good reasons to choose Python over MATLAB. One is it's becoming almost the universal programming language. It's the most popular current scientific programming language. It has a purity about it, which MATLAB doesn't have. It teaches you proper programming. And of course, it's non-proprietary, so it's free to air, which is a big advantage when people leave the course. And then in the delivery of it, we're going to have a pre-MSc course module, which is based on the materials provided by my school, which is, I've done it now, and it's really cool and it's really good. And that module is an online module, but it's going to be supported by postdocs and members of GSTT staff to develop those skills, those early skills. And then the students are going to apply them in that first term to our medical statistics module. That's going to be taught with Python. And our signal analysis module will also be taught with Python. And then further along the line, in our second year, we'll have our data analytics content, which will be further expressed with Python. Next slide, please. So yes, I'll try and skip through these as quickly as possible. But like I said, these first term modules are really the foundation modules for the training rotations that the students have. An important thing we've done here is combine the former clinical measurement module that we did with their anatomy and physiological submodule. And the strategy here is to have some clinical knowledge presented by a medical expert, say, supported by a clinical engineer who will describe some mathematical or modeling technique applied to that system. And then we'll have a clinical measurement expert coming in at the end of a day, and they'll describe the measurements made in respiratory, in urology, etc., whatever the day is concerned with. And we hope that this will integrate students' knowledge. So they'll have basic anatomical physiological knowledge supported by the application of clinical measurement. Next slide, please. We have a 30-credit module in Introduction to Clinical Engineering Practice. It's a bit of a misnomer because we're going to include lots of things in here, lots of things about professional practice. We're going to have introductions to healthcare technology management and rehab. We're also going to visit our sister discipline, medical physics, and we're going to do it very differently to what we've been doing it in the past. In the past, we've explored medical physics with medical physics students, and this time we're going to take a particular angle on it. What do clinical engineers need to know about medical physics? We'll be adopting a systems approach throughout the course, and so part of clinical engineering here will be to begin that process of starting to map relationships between departments, between hospitals, within a unit. Next slide, please. We've got a new module called Healthcare System Design. We're very excited about this one. We've got some partners through Didi Akinlui, who's one of our members of staff here, with the Cambridge Engineering Design Centre. The Cambridge Engineering Design Centre were a big influence on engineering better care, and we're borrowing on these experts to come and help us deliver a course in healthcare systems design. So that's really about how you use mapping and analytical tools to improve services. And so that's what that's going to be about. Next slide, please. Skipping through. We've already got a very successful module in healthcare technology design, but this time we'll be putting it in year 1, semester 1. So this is about designing and developing devices, and people will be understanding, you know, the acquisition of user requirements, development of specification, verification and validation, and all those things. It's one of the modules that students really like, and I think we're keeping this pretty much as it was before. Next slide. And then in the second year, second term, the students already have done an intro to healthcare technology management. This time we'll turn our attentions to leadership and innovation to support the specialist training competencies. Here we'll have lectures on risk management, on optimizations of systems. We'll introduce some aspects of clinical computing that we haven't covered previously. And we'll talk about leadership in developing systems and improvements for healthcare. Next slide. And then data science for clinical engineering. This is a new module. So we're going to talk about, this is where analytics pillar really comes to have a big role. We're going to talk about developing analytical skills within our cohort, particularly machine learning, AI skills, etc. And the students will get data, real data, that they will have to have strategies for the analysis of. So we've got a big clinical analytics team here in our trust, and we will be combining with them to provide data for the students to perform data analysis on real data. Clinical practice for clinical engineers. This supports the patient pathway. Next slide, sorry, please, Steph. Clinical practice for clinical engineers. Caroline's talked about the patient pathway. And there are formal methods for talking to patients, for investigating patients, for summarizing patients in reports. And we're going to explore those in this module. We'll treat the patient as not just a disease entity, but as a person as well. Isn't that a surprise? And we'll talk about their psychological and social aspects of their disease. We'll have skill development in this module. We do it already. We get the students to do mock interviews, mock history, taking mock assessments. So that's cool. Next slide, please. We do a research project, of course, 60 credits, a third of the module. This time, we used to do research methods in year one, which seemed a bit silly now on reflection. We're now going to put research methods in late in year two, and the students will have lectures on ethics, methodology, design, statistical analysis, further statistical analysis, etc. Projects are conducted in their local NHS hospitals, but with support from the academics here at King's. We already have regular team meetings with our students, but we'll probably increase that. We're going to change the style of the project reports, so they will be more like an academic paper style. Previously, they've been 30 or 40 page long theses. Okay, that's, I think, it from me. Handing back.
Okay, thanks, Adam. Right, I think we need to be really fast now because I'm afraid we are running out of time and we are going to overrun, so I'm very sorry. We'll quickly go through the core modules. These, I haven't got very many slides here at all. So Stephanie, if you go on to the next slide for me, that would be great. So I'm going to quickly talk to you about 4 core areas. So Stephanie, if you could do so the professional foundation of healthcare science, which was what the professional practice was, research skills in healthcare science, this STP project, and then this individual professional development, which has replaced the elective. So next slide, please, Stephanie. So the professional foundations for the clinical healthcare sciences are 20 credit modules. So there are 20 competencies associated with it. I've just taken out a few of the themes that are associated there, and I just sort of did a quick brainstorm as to possible ways that we as clinical engineers could actually support those. Now, the first one, well-being. Somebody talked to me about having a well-being, a kind of a me user manual. If we could have a space bar, please, Stephanie. So a user manual for me. This is really something that we encourage training officers to sit down at the beginning of the programme with their trainee and outline what sort of support the trainee is going to get, what support the trainee will request in order to ensure that their health and well-being is maintained. Right, I think probably due to time, Stephanie, if you could just go right the way through, and I'll just sort of pick up anything. Oh, okay, anything. I think the main thing I thought of was the EDI, that sort of quality, diversity and inclusion, obviously very important now. Now, as engineers, we could look at that from the perspective of accessibility to medical devices, and certainly in the news recently has been the pulse oximeter, and the effect of ethnicity with that. Okay, so the next slide. There's only one competency in this slide, but really it is just to ensure that the workplace, or two competencies, that the workplace is aware of the project and it is embedded into the workplace, which I don't think has ever been a problem with clinical engineering because of the way that King's works with that project. So it's really just to make sure that the workplace is aware and is able to offer support to the project. Next slide, please. So again, the project, again, it's ensuring that the workplace has the input into the project and supports the trainee doing the project, and that the project is what the workplace actually needs in order to move forward. Okay, next slide, please. So this is also another quite exciting bit, is the individual professional development. So really it's looking at areas that the curriculum doesn't cover, and it's looking at the development needs of both the department and the trainees. I know Caroline talked about at the beginning how it would be if the department had a use to go and find out what another department was doing, why not make use of it? This is even wider sense than that. If there's some aspect that you as a department would like to know, send your trainees out to find out about it. Other things that they could do is spend time within the medical device industry, perhaps go and spend a week or two, see what goes on out in the private world, visiting different clinical engineering departments. Perhaps if your engineering department isn't based within medical physics, send your trainee to one that is, and vice versa. And then again, visiting those departments that make use of the clinical engineering services, and just understanding also with the changes of what's going on in the NHS, perhaps understanding the support of needing to support community equipment as we have much more care in the community going on. So they're just a few suggestions that I came up with. This is the most imaginative module there is. So yeah, sit down with you and your trainee and work out the best way to make use of that. Right, okay, next slide. Okay, conclusions to my bit. Basically, there's two of those modules that really shouldn't take any extra work, as what's happened in the past, because you've always supported an MSc. The core module completion, again, providing you have training plans in place, then they should naturally fulfill the competencies with the professional module, and then the IBD module, just be imaginative. Okay, finally, next slide, that's it. We'll just do one conclusion slide, which, to be honest, Adam wrote for the academic side of things, but actually it fulfills the work-based slide. We really are looking for a versatile engineer who can work across clinical disciplines, and we're looking at the development of analytical, practical and patient skills, and making sure that the emergence of the clinical engineering cohort influences positively outcomes at all levels of the hospital and clinical services and the patient. So sorry we've overrun. We've just now got the opportunity to possibly field a few questions. And also to decide whether we would like to, whether the community feels that it is useful to set up a clinical engineering training network. So can I ask people just to have a show of hands if you would be interested in helping form that network and meet with that network in the audience? How many hands have we got up there? Yeah, plenty of hands there. Great. Okay, I'll do a print screen of that. Excellent. Okay, well, I think we will sort that out and work that one forward, and I will send out dates as and when. So Stephanie, do you have any questions in the chat that you?
Yeah, I think they're for Adam.
Right.
Will trainees have access to all software required, e.g. for FEA competency via university, if we don't have them in our departments?
Yes, I mean, as people will be aware, there are lots of open source alternatives for many of these things, where they're not available through King's. Of course, King's students have access to all the software that King's has available. So there are lots of different softwares that King's has available, and where they don't, for example, next week I'll be looking at segmentation with a very particular free-to-air software. We'll make sure that they're pointed in the right direction.
Okay. The same person was wondering if they need to factor in time for trainees to complete the pre-course Python module during their trust induction time in September.
Yes, that's probably true, actually. It's only a couple of days. And normally we start on the Wednesday of the opening week, whereas probably we always should have started on the Monday. So Monday, Tuesday of that opening academic week will probably be dedicated to the Python programming.
Okay, and have you considered teaching R, which is more suited for statistics and AI than Python, and is also free?
Well, I don't know if I agree about R being more suitable for AI or machine learning, but we can have that discussion elsewhere. What I agree about R for statistics, however, and R is based on Python. The challenge, I guess, is not confusing the student with too many different programming languages. Getting them really skilled in one is probably more advantageous than using different programs to meet the needs of a particular statistics or AI application.
Okay, thank you.
Any other
There's no more questions.
Okay, well, thank you very much for attending, and I'm so sorry that we have run over by almost 10 minutes. If you would like to do one of the school generic drop-in sessions about the new curriculum, then those dates are on our website. But what I'm hoping to do is set up a more specific one for clinical engineering, since there has been so many changes, and that we can do a drop-in and look at being able to answer specific clinical engineering questions. So good luck with all your training plans getting together for your accreditation. We'll set up that clinical engineering network as well, so that you can have the support of your peers when you set up those training plans. So thank you very much.